Two used oil analysis reports. Same brand, same product line, same extended drain interval. Pull up the additive columns on both, and the molybdenum is identical. The boron is identical. The calcium, the magnesium, the zinc, the phosphorus, all identical. The total base number at the end of a 7,000-mile drain is identical. What you are looking at when you compare Mobil 1 Extended Performance 0W20 and 5W30 is not a competition between two different formulations. It is the same oil in two different viscosity grades, and the used oil analysis removes any ambiguity about that. The only question these reports are actually answering is whether you picked the right viscosity for the engine you are running it in. The kinematic viscosity at 100 degrees Celsius is where the two reports diverge. 0W20 comes back at 7.8 to 8.3 centistokes after use. 5W30 comes back at 9.6 to 10.1 centistokes. Both grades hold their windows. 0W20 stays classified as a 20 weight. 5W30 stays classified as a 30 weight. Mobil 1 Extended Performance holds that grade integrity through an extended drain interval without drifting out of specification. But the operating difference between 7.8 and 9.8 centistokes is not trivial. That gap is the hydrodynamic wedge, the film of oil that keeps rotating and reciprocating surfaces separated at operating temperature. A thicker film requires more energy to shear through, which increases internal fluid friction and costs fuel economy. A thinner film delivers oil through tighter passages faster, reduces that internal friction penalty, and is specifically what modern tight-tolerance engines with narrow bearing clearances were designed to use. Original equipment manufacturers specify viscosity grades based on actual engine geometry. Bearing clearances, oil passage diameters, the intended operating pressure window for a given pump volume. These dimensions were set during engine development with a target viscosity in mind. When an original equipment manufacturer specifies 0W20, the engine's lubrication architecture was built around a fluid that flows at approximately 8 centistokes at operating temperature. The 5W30's 10 centistokes does not deliver a better oil film in that context. It delivers a thicker fluid through passages sized for a thinner one, which raises oil pressure readings without improving film coverage at the contact zones that matter. People who step up to 5W30 thinking they are adding a safety margin are adding flow resistance instead. The fuel dilution column is where the viscosity difference creates a practical vulnerability for 0W20 owners in specific driving conditions. Mobil 1 Extended Performance 0W20 carries a moderate fuel dilution tolerance rating. The 5W30 carries a high rating. During cold starts, raw fuel washes past the piston rings and enters the crankcase before combustion temperatures stabilize. In turbocharged direct injection engines, that dilution cycle runs on every cold start without exception. Short trips compound the problem because the crankcase never reaches the sustained operating temperature needed to boil off accumulated fuel. When fuel dilution enters a 0W20 crankcase, the viscosity floor drops towards 6.9 centistokes, the lower boundary of the 20-weight classification window. At that point, the oil is approaching the minimum acceptable film thickness for 0W20 applications, and the hydrodynamic wedge is under real pressure. The 5W30 starts that same dilution cycle at approximately 10 centistokes and drops toward 8 centistokes under comparable contamination load, which keeps it well inside its operating window with meaningful buffer remaining. If your driving pattern is dominated by short cold trips in a turbocharged direct injection engine and your original equipment manufacturer specifies 0W20, this is the wear condition to monitor. The oil is not defective. The operating environment is punishing the viscosity grade. The total base number data removes any ambiguity about which product has stronger acid neutralizing chemistry. Both grade reports come back at 2.8 to 3.6 milligrams of potassium. Hydroxide per gram remaining after 7,000 miles, starting from 8.5 milligrams of potassium. Hydroxide per gram fresh. The depletion curve is identical. The calcium detergent package running at 1,000 to 1,200 parts per million remaining. and the magnesium package at 650 to 800 parts per million remaining are identical between the two grades. Acid load from combustion byproducts does not discriminate by viscosity grade. The chemistry that handles it is the same in both bottles, in the same concentration, and depletes at the same rate. Where metals land within a narrow range across both reports, iron comes back at 8 to 14 parts per million in the 0W20 and 7 to 12 parts per million in the 5W30. Copper runs at 2 to 5 and 2 to 4 respectively. Aluminum and chromium are identical between both grades, in the range of 2 to 4 parts per million for aluminum and 0 to 1 for chromium. A slight 5W30 edge on iron and copper is visible in the data, consistent with what a marginally thicker hydrodynamic wedge delivers at cam and bearing contact zones. Neither reading in either grade is alarming for an extended drain interval. The boron dispersancy package at 120 to 160 parts per million remaining, and the zinc dialkyl dithiaphosphate anti-wear reserve at 750 to 850 parts per million zinc and 650 to 750 phosphorus are both identical between the grades, both in a range that confirms the additive package is not exhausted at 7,000 miles. The viscosity index reading tells a technical story that runs counter to what most people assume about thin oils. Viscosity index measures how well an oil resists thinning as temperature increases. A higher number means the oil's viscosity changes less across the range from 40 to 100 degrees Celsius. 0W20 in this report carries a viscosity index of approximately 170 to 175. 5W30 carries 165 to 170. The 0W20 has a slightly higher viscosity index, meaning it is comparatively more stable across a temperature swing than the 5W30. That is a function of the polymer modifier package required to achieve the low cold weather flow rating in a 0W grade. The practical implication is that 0W20 is not simply a thinner version of 5W30 with worse thermal stability. It is a formulation engineered to flow more freely at all temperatures while maintaining a tighter viscosity response to temperature change. And its application is defined by the engine geometry it was designed for, not by whether a thicker grade would feel more conservative. The verdict for this comparison is simpler than most. Additive chemistry, acid neutralizing reserve, and drain interval capability are not differentiators between these two grades. Mobil 1 Extended Performance 0W20 and 5W30 are carrying identical chemistry to the contact zones of different engines, and the used oil analysis confirms that completely. 0W20. In an engine designed for 0W20 delivers reduced fluid friction, fast cold start oil delivery through tight passages, and the same extended drain capability as the 5W30. 5W30 in an engine that calls for 5W30 delivers a thicker hydrodynamic wedge under heavy thermal load and better fuel dilution tolerance for turbocharged direct injection applications in demanding short trip conditions. The used oil analysis confirms they are the same product. The engine specification tells you which version of that product belongs in your crankcase.